Welcome to all. This will be a demo class for the course Finite Element Method, in short form very popularly called FEM, for M.Tech Structural Engineering. Now, I am going to start the course on 10th August 2022. See, my main purpose or aim will be to complete the syllabus in around 2 months, that is say around first week of October. Preferably, if possible, I will try to complete by end of September. Now, class timings, I have written here 9:15 p.m. to 10:30 p.m. because I got other classes till 9 o'clock. Small break after 9 o'clock, 9:15, 10:30. Usually this time people don't study. So, you can utilize this one and study daily. Monday to Friday. Saturday I got a little extra time, extra class, so I may not be able to take right now, but I will change it later if possible. And to complete within time, if I find that more time is required, I will put some extra classes by discussing with the people who join the batch. For general public, I don't have to tell it. So now at present information is 9:15 p.m. to 10:30 p.m. Monday to Friday. For this is main coverage will be for M.Tech structures. But this course will be useful even for those who are interested in studying M.Tech. So many people inquired me also that I want to study FEM thoroughly. Thorough FEM class means with the full fundamentals all. Right now not possible. But if they are studying themselves, they get so many doubts. So therefore, in this course, brief course, see, short duration, they get so many ideas. See, today, I will tell you, today I am covering a term called shape function. I will let you know about it little later. Now, if you are interested in studying finite element method and understanding thoroughly and master it, you need basic concept. All the basic concept will be covered in this course. See, for example, you will be knowing what is the meaning of coordinate system for 1 dimension, 2 dimension, 3 dimension system or elements, and then also how to find shape function, which is very, very important in finite element method. Then how to develop stiffness matrix, how to assemble the global stiffness matrix, how to analyze by stiffness matrix, isoparametric elements, and then how to find consistent nodal loads, then further strain displacement matrix. They are all integral part of FEM. That all will be covered here. So, if you are studying yourself, not writing examination, this course will give you good basic idea so that based on that one, you can develop the skill and learn later. Okay. Now, those who want to join this batch, you can send either WhatsApp message or call number given here, 80886-03637. Now, suppose you want details more. For example, actually I have prepared a brochure, just 1-page brochure. So therefore, that brochure contains what I am going to tell here only, briefly in just 1 page. Still, some people want the brochure. You can WhatsApp and send a message, I want details. Better mention your name. Or if you decide to join the course, then you can message there that willingness to join, or you can call me. I will give further procedure. And regarding the course fee, I will not talk here because in the classroom I never talk about those things. But it is my profession. So regarding that one, you can go through the brochure where it is given there. And now, further about this, I will not discuss now because this is information to be passed for those who are joining. 10th August I am starting. So class will be in Zoom, and any further changes I will mention if required for better quality. And recording of every class will be available on the same day. So those who by chance missed any class, they can go to recording several times. Recording will be almost there up to end of the course. Okay, now I will leave this one because I will come this side. This is subject, structural knowledge. One small point. I mentioned demo class. Remember, even though this is a demo class, correct, because briefly I am covering, but I never distinguish between a demo class and a real class. Even if it's a demo class, I give full details like usual class. And one more thing, demo class why require so many people, they want to know how the teaching is done, how I teach. So for them to realize or to understand what way I teach or whether they feel that they can learn something from me, for them demo class. So now come this side, never bother about this side now. I will come to shape function. Now subject matter. See, FEM, so many things are there. Today for demo, I selected shape function. Symbol is N. So many times shape function, even those who passed M.Tech, you ask them, what is shape function? They will tell N1, N2. Then I will tell them, N1, N2 are symbol. Tell what is shape function means. Then they will start giving formulas. One, two-noded line element, L minus X by L, X by L, or if you do natural coordinate, 1 minus R by 2, 1 plus R by 2, or three-noded, or beam element, where theta and vertical displacement both are there, or four-node element, they will start giving formulas. That is formula. What actually means shape function? Majority will not answer the question. Why? It is actually very sensitive part of the FEM. So first I will do one thing. I will give a small introduction to this element, and then I written something here. This is a practical example for you to understand shape function. See, usually I never write this in the class before the class. Why I write? Because time constraint. Otherwise, if I am going to write all this, I will dictate in the class and write, not pre-prepared. I never take a pre-prepared class, and I bring nothing to the class except one pen and eraser. You see, but before going there, shape function N, today's coverage for a two-noded line element. Line element is sometimes people call line element or a truss element, only axial deformation considered, means shortening or elongation. That is U, symbol is U for horizontal member U. Suppose in case of beams, vertical displacement is there, it is V. And for beams, rotation is there, theta. That all comes in the course later. Okay. Now, consider a two-noded line element of length L. See, length L here, 1 and 2 are the nodes at the ends. Let U1 be displacement at node 1, U2 be displacement at node 2. Now remember, whatever displacement takes place at 1, it can be right side or left side. But later, sign will be there, we will take right side, that all will come later. Okay. U1, how much displacement at node 1, how much displacement at node 2, that is U1, U2. See, you can make a note there if you want. See, some small note you can write. U1 and U2 are called nodal displacement. Nodal displacement. I'll tell you why, reason. See, in finite element method, which is actually by matrix method only, stiffness matrix method, you find displacement at the nodes. Then, using the displacement at the nodes, you analyze, or later you can find displacement anywhere in between. That is actually by using shape function. I will further give information for that one. Now, consider, see, 1 and 2 are nodes, end point, fixed points. Consider any point P, randomly a point P, any point P. Let U be displacement at P. See, here U1, here U2, any point P, displacement is U. Now, note, if the P comes here, U becomes U1 at node 1. If the P goes there, U becomes U2, that is node 2. U without suffix is anywhere displacement. When I put U1 or U2, it is displacement at 1 and 2. Simply U means U at P, any point. Now, we have to get the U using U1, U2 and also using shape function N. Now, let N1 and N2 be shape function at P, value of shape function at P with respect to displacement at node 1 and node 2. Means at any point P, for this point, with respect to displacement at node 1, U1, shape function is N1. With respect to displacement at node 2, shape function is N2. Then by definition, displacement, see, by definition, In the class before coming here, I'll give lot of information. Now I will give an equation, you have to accept it. Now displacement anywhere, that is at P. See, if displacement is U1 here, displacement is U2 here, what is displacement here? P equal to U at P equal to 1 minute now. I will leave it as it is now. Now I will come to a practical example. Usually in my class, actually in structural analysis, not much. In RCC or steel, I give plenty of practical examples. So many times people fail to understand the concept. Some practical example, usually money matter or some spending somewhere or riding a vehicle regarding the limits all, people understand very easily. So right now, this is outside FEM now. Just to make you clear what is shape function, I will give an example here. So what I am going to write here is not for FEM. See, no, I written 1 and 2. Now 1 and 2 are the nodes there. Here, imagine 1 and 2 are two companies. Two companies, 1 and 2. Or firms. Okay. Now, imagine for some work, they take contract. Company 1 gets a contract for, say, 20 lakhs. Remember, that is whatever amount is allotted for company 1. That is, this 20 lakhs will become your U1 later. Imagine company 2 gets a contract of, say, 30 lakhs. 30 lakhs. Okay. Now, they give subcontract. See, imagine a person P, independent person P, he gets subcontract. He gets subcontract from company 1 and also company 2. What percent? Imagine company 1 gives subcontract to P around, say, 60% of the allotment, and company 2 gives only 30% of allotment. 20, 30, 60, 30, okay, I'll put not 30, I'll put 25%. 25% of the allotment. See, these are nothing but shape functions. Means whatever allotted for company 1, 60% subcontract they are giving to P, and company 2, 25. Now, why higher value, why lower value? Because, see, P is nearer to 1. It is near to 1. Far away from 2. Or this person is more closer with company 1 and just he knows company 2. He is a good person, a person, competent person. Company 1 believes him more. Company 2 believes him, but not to that extent as company 1 believe. So company 1 decided, I will give 60% subcontract to him. Company 2 decided, I will give 25% subcontract to him. Now, I will ask the question in the class. Tell me, total contract, how much P will get? See, that one, how much total get? So, what P get, what total P gets is U. Displacement anywhere equal to, now all will tell the answer because 60% of 20 lakhs is actually 12 lakhs. 25% of 30 lakhs is 7.5 lakhs. Therefore, he will get 12 lakhs from company 1 plus how much? 7.5 lakhs from company 2, or he will get a total contract of 19.5 lakh rupees. Okay, Indian currency rupees. Or 60% you can call 0.6 in decimal form. 25% you can call 0.4, or you can tell company he gets once again equation. How I got 12? It is 20 lakhs, or I'll do one thing. First I start from number here. It is 60% of 20 lakhs. So 0.6 times of 20 lakhs plus 0.25%, 0.25, not 25% of 30 lakhs. Add it, it becomes 19.5 lakhs. Now, this is your U1. This is your U2. Nodal displacement. How much displacement here? How much displacement here? Because of the two nodal displacement, what displacement is at P, by shape function, this is your n1, this is your n2. Therefore, I can tell u anywhere equal to n1 u1 plus n2 u2. Very simple to understand. See, whatever displacement at node 1 is there into n1, if it is 60% into 0.6. Whatever displacement at node 2 is there, u2 into n2, say 25%. Okay, now this is regarding P. Now do one thing. Take another person Q. Whereas imagine Q is closer to company 2. Imagine he gets 80% from company 2. Why? More closer. Company 1 will give him only, not see anything, 80% there. This company will give you only say 12%. They decided. Whatever 20 lakh is there, 12% of that we will give contract to Q. And this company will give 80%. Last time I told 25, already 25% gone. So I'll do one thing, not 80%, 70%. Okay. Why already 70%. Okay, now tell the answer. Therefore, how much is for Q is directly 12%, 0.12 of 20 lakhs plus 70%, 0.7 of 30 lakhs. This will be 24 or 2.4 lakhs, and that is 21. Total will be 23.4. If any calculation mistake is there, adjust it over. Now see, once again, n1 u1, n2 u2. For the point P, n1 I told 0.6, n2 I told 0.4. For this one, I told n1 equal to how much? n1 equal to some 60%, and I told not 60%, 12% and 70%. Actually, remember, some percentage still remaining. Later you can make out, when you add the shape function, you can make out some important information and not considered any summation theory here. Actually, at any point, n1 plus n2 will be equal to 1. If 3 nodes are there, see, by chance, if 3 nodes are there, then n1 u1, n2 u2 plus n3 u3, that way. Then u1, u2, u3, any number of nodes. So, general formula for u will be n1 u1, n2 u2, n3 u3, n4 u4, like that, based on number of nodes. Now, for a 2-noded line element, I will explain here how to get shape function n1 and n2. Okay, I will rub everything here, write fresh now. See, this much statement, suppose you write examination. Remember, this is not required. Don't write money matter there. Now, this much all you don't require. This I wrote to make it clear. Suppose a question is solved in examination, briefly you have to write. I will write that much only here. But while writing, I may explain furthermore. Those who are interested should note down that one. And one more thing. See this, it is called as demo class, but I call real class. If anybody who does not join the batch, even then, later he should tell something. What? That class, one demo class was there, he will call demo class. I have gone through that one. Shape function meaning is fully clear to me, and I know how to find shape function for a 2-noded line element. At least that much. He should tell whatever he told is clear. It is helpful for me, not me, for that person. He should tell that way. Okay, now I will rub and start the technical part. We will start. I have written something because, again, time constraint. Because if I write everything in front of you, I may be able to finish only Cartesian coordinates. I would prefer to finish even that natural coordinate also, so that let it be complete. See, therefore, start fresh. I will explain. Question. Find shape function for a 2-noded line element considering axial deformation. They will not mention in the question. They will just tell line element. Over. Considering axial deformation, understood. Deformation, understood. Based on Cartesian coordinate, that is x, y, z, like that. Here one dimensional, only x. That all you write. That is x. See now. First, consider origin for x at the left hand. You should write. Those who are interested should write. element, see, you write 1 and 2 here. At 1, displacement is u1, this is x1. For node 2, displacement is u2, x equal to x2. Here x1 equal to 0. Why? Because we are taking origin here. That all you write. Those who are interested write. Since you consider origin at the left hand, for left hand x equal to x1 equal to 0. For right hand x equal to x2 equal to L. Length is L. Let consider u right side be displacement at any point P. See, any point P for which displacement is u and distance is x. Over. Now consider polynomial for first degree for u. Okay, 1 minute now. In the class I will see later in course this will be thoroughly explained. Now time factor. See, briefly I will tell. For a two-noded line element, we consider linear variation. Y equal to mx plus c, that way. Therefore, you write a polynomial. But here, now I don't want y equal to mx plus c. I want u equal to one constant, say a1 plus a2 into x. Suppose 3 nodes are there. a1 plus a2 into x plus a3 into x square. 4 nodes. a1 plus a2x plus a3x square plus a4x cube. That way it will come. These all I will explain in the course. Here if I tell about the polynomial, time will be consumed. Purpose is not served. Okay. Now those who want steps, you can write now. Sketch the element with the nodal displacement u1, u2. Take origin here, Cartesian coordinate x. Then write x1 and x2. x1 equal to 0, x2 equal to L. Mark any point P for which general displacement is u, distance is x, means from here to here is x. Now, write the equation for u in the form of y equal to mx plus c or u equal to a1 plus a2x. U is general, not u1, u2, anywhere. Okay, now, write this in matrix form. How? Same follow. U, if you write a matrix form, actually later u will come, v will come, w will come. If it is a beam element, then you have got v1, theta 1, v2, theta 2, that all comes in the course. Here, simple. U, matrix form equals, see, 1 and x, a1, a2. Check here. 1 into a1 plus a2 into x, correct. Or, in the class, I'll give a note. Variables first in the horizontal line. Somewhat crude method, but helpful. And a1, a2 should come in the vertical elements. These all hints I will give in the class. I will give a note for you also. Call this as equation number 1. Then you tell this one, wait for some time. Come to boundary conditions. Boundary condition means displacement u1 and u2. Start. First consider node 1. Consider node 1. For node 1, your displacement u becomes u1 and x becomes x1 equal to 0. Okay, start. Substitute in the original equation. Don't substitute here. Substitute in this polynomial. What do you get? U equal to u1, where is it? U1 equal to a1 plus a2 into 0. Some will tell zeros are not required. No, 0 is required. I will tell you why. Later I will tell you. Now, consider node 2. For node 2, u equal to u2, x equal to x2 equal to L. Substitute. u2 equal to a1 plus a2 into L. Okay. Now I will tell, write these two boundary conditions. If 3 nodes are there, 3 boundary conditions. What do you get? u1, u2, u3. 4 means 4 conditions. Write in matrix form. In the class I will tell, this is the way you are to write. Left side u1, u2. Right side a1, a2 should come on the last in this way. And other coefficient should come here. See, u1, u2 equal to 1, 0. That's why I told 0 required. Suppose write only a1 here. People start searching. Where is next element? See, 1, 0. Then 1, L, a1, a2. Now, immediately, see, remember, we want a1, a2 here. So, shift a1, a2 other side. So, a1, a2 will become inverse of this one. This is simple mathematics. See, inverse of this matrix into u1, u2, call equation number 2. Now, do one thing. You call this as matrix A. Matrix A. Okay. Now, very, very important to get, see, I'll put a line here now. I can use the space here. See, now, to get A inverse, first of all, for those who are studying M.Tech, if they do not know how to inverse a 2 by 2 matrix, they are not fit for studying finite element method. But even then, in the course, first in the beginning only, I will tell requirement for finite element method. In the finite element method, during shape functions, you have to inverse sometimes 2 by 2, sometimes 3 by 3, sometimes 4 by 4, even 6 by 6 also is there. There I will tell you, 4 by 4 or 6 by 6, very time consuming. That result you can remember. Examination they permit. You can write, we know that inverse is so and so, they also permit. But 2 by 2 or 3 by 3, they will expect you to show the calculation. So there I will explain to you how to inverse a matrix. Now, I will not explain much here. Remember, briefly, silently I will write here. See, A inverse. Those who are interested, note down. A inverse equal to adjoint of A divided by determinant A. Determinant A. Okay, now, first, adjoint A. Adjoint A we require. To get adjoint A, first get A transpose. First get A transpose. Transpose means interchange. 1, 1, see here. 1, 1, 1 this way. 0, L. Okay, A transpose. Okay, next. Now write, therefore, adjoint A. Adjoint A equal to, see here. Here element. Cover this row, cover this column. L will come here. L. Cover this row and cover this row, cover this column. 0 will come here. Next, cover this row and cover this column. 1 will come here. And cover this and this, again 1 will come. Then alternate plus minus, then minus plus. See, plus it is, minus there, and here it is minus, and then plus. That you have to practice. Anyway, that first of all, I should not have told this one. Now, determinant A. Determinant A will be equal to, see here, very simple. For A matrix, 1 into L minus 1 into 0, it is 1 into L minus 0 or equal to L. So I will write here, therefore, your A inverse equal to, adjoint A is what? It is, determinant is L. 1 by L times L 0 and then minus 1 and 1. First of all, in the demo class, this will be a time waste because nobody in the demo class will tell you how to inverse a 2 by 2 matrix. Okay, now start. Now correctly do one thing. Substitute into, correct steps now. 2, where is 2? Here. Here, see. Therefore, I will do one thing now. Okay. A1, A2 equal to, inverse of this matrix is 1 by L into L0 minus 1, 1 inverse into U1, U2. Now see, correct the steps now, U1, U2. Okay, now, this is called new equation. I will call this as, actually it is 2 only. It is actually 2 only. So I will call this as 2 dash. Why? Because it is not a new equation, substituted 2 dash. Now, substitute 2 dash in where 1, the main equation. That is, you get here, see, your general U matrix form equal to 1x. X is a variable. I use red color. 1x into A1, A2 is 1 by L times L0 minus 1, 1 into U1, U2. Or I can tell your U equal to, see, U matrix equal to 1 by L, I will push outside, see, 1 into L minus x into minus 1. It is L minus x. X is to be, actually red color not required, L minus x. Then 1 into 0 and x into 1 is, after some space, x. Close. into u1, u2. Stop. Now, no numbering required here. See, remember this one. We got u in matrix form in terms of u1, u2. Now do one thing. We have u equal to, I already told you, equation for u. What? Your u equal to n1 u1 plus n2 u2. This already I told you earlier. U equal to, or once again write matrix form, or your u equal to matrix form equal to, see, n1 n2 into u1 u2. Now compare these two. Therefore, we comparing, actually not required, comparing. You can write equation also. If you want, you call this as 3 and call this as 4. Compare 3 and 4. You get n1 equal to, see, n1 equal to L minus x by L. L minus variable is x divided by L, and n2 equal to x by L. Where is it? X by L. This is value of shape function, final answer for a two-noded line element. Okay. Answer is over. Now, I write over. Now, I see the time there. If time available, I will even consider natural coordinate also briefly, so that let it be complete. Okay, I will first remove this one. Remember, later I will write n1 equal to L minus x by L, n2 x by L, or the formula is, if you want any point here, n1 equal to, see, if this is x, this is L, n1 equal to this distance by L, n2 equal to this distance by L. These all I will explain in the class, in the course, how to remember. So you got n1 L minus x by L, L2 is x by L. At present, for what you call demo class, I don't call demo class, sufficient. Okay, I will prepare for natural coordinate if time is there. Okay, little time is there, we will use it and get the natural. See, little fast I will tell. Remember, here fast because of time restraint. Question, once again write the question. Find shape function for a two-noded line element considering axial deformation based on natural coordinate. Now, what is the natural coordinate? I will tell, if possible, at the end of this class, only if time permits. Otherwise, in the course, not that way. Before you start shape function, I first define what is Cartesian coordinate, what is natural coordinate. In the class, for different points, how to get natural coordinate will be thoroughly explained. You only will tell the answer. So, right. Now, time being, what I write, you accept it. See, this is R, this is X. Now, remember now, when R means from center, you are going right side. That is very important. Later I will tell, or today you believe me. No. If this is X, this is R. Now, we are not using X. Remember, you are using R. See, node 1, U1, node 2, U2, node 1, R equal to R1, R equal to R2. Remember, in the class, thoroughly you will be knowing, all will answer. Left hand node, what is R? They will tell, sir, -1. Right hand node, what is R? +1. So today, R for left hand is -1, R for right hand is +1. Or remember, when somebody teaches you shape function, he will tell, by this time, you know the natural coordinate. So you are supposed to know. When you reach here for shape function, before that you know natural coordinate to tell the answer. But still, if time is available in the end, I will explain. Okay. This, remember, left side R is -1, right side R is +1. Okay. Consider any point P for which displacement is U. Let R be natural coordinate with originate center for P. Consider first degree polynomial for U in terms of R. I will keep on rub and write it now. See, U equal to write A1 plus A2 into R. This is to understand. See, this will make you more clear. I am changing previous to new one. A1 into R. Okay. Now, further. Write in matrix form. U equal to 1 into not x. I use finger only. 1 into R into A1, A2. Boundary condition. Consider node 1. See, U equal to U1 and your R equal to R1 equal to minus 1. I told you. Substitute. U1 equal to A1 plus A2 into minus 1. Okay, start. Consider node 2. U equal to U2. And then this is R red color. R equal to R2 equal to plus 1. Substitute. U2 equal to A1 plus A2 into plus 1. Or write in matrix form. U1, U2 equal to 1 minus 1, 1 minus 1, and here what 1 into A1 A2, or A1 A2 equal to 1 minus 1 1. This is to be inversed into U1 U2. Say matrix A. Okay, come here. To get A inverse, first you require A transpose. Transpose A. 1 will become here 1. Then minus 1. Write adjoint A. Adjoint A is matrix of cofactors of A transpose equal to, see here, if I cover this way and this way, 1 will come here. If I cover this and this, minus 1 will come here. If I cover this one and this, if I cover this one and this one, 1 will come here. If I cover this and this one, 1 will come here. Now plus, minus, plus. See, you are after, right? Anyway, I told inversion I will not explain here. Now, determinant A equal to, very simple, see answer here, A matrix. Determinant A equal to 1 into 1, see here, 1 into 1. 1 into 1 minus of 1 into minus 1, or equal to 1 plus 1 equal to 2. Therefore, A inverse equal to 1 by 2 into adjoint, where is adjoint? 1, see, 1, then minus 1. This is A inverse, 1, minus 1. Inversion, if it is not clear, you study yourself only. I told, but even then, briefly I told, so that you can learn. Substituting 2 in 1. Okay, now I will remove everything now. Why? This is becoming difficulty. Rubbing. Okay, I will remove everything now. Write fresh now. Anyway, remember, lastly, answer also, I can write the answer. No, later I will write. Okay. You will get 1 minus R by 2 left side, 1 plus R by 2 for right node. Okay, now start. Substituting 2 in 1. Substitute this 2 in 1. Where is 2 in 1? Substituting 2 first. Where is 2? 2 is here. See? 2 is here. You get A1, A2 equal to inversion of, see, this inversion of the matrix is 1 by 2 into 1, minus 1, 1, minus 1. Then, where is it now? A inverse into U1, U2. A1 equal into U1, U2. Okay, U1, U2. You call this as 2 dash. Now, substitute 2 dash in 1. Already explained for you. You get general U equal to, U matrix equal to, see, 1R into A1, A2 is half of 1, minus 1 into U1, U2. Or you can tell equal to 1 by 2, or U equal to, see, I'll complete 1 by 2 into 1 into 1 minus R into minus 1. It is 1 minus R, then 1 into 1 plus R into 1. It is 1 plus R. 1 plus R is the expression for U. Okay, now, if you want, you can write some number here. Sorry, forgot. Into what? I forgot that one. into u1, u2. u1, u2. Okay, this is, you can, if you want, you call some name. Now, we have u in general formula equal to n1 u1 plus n2 u2. Or if you write a matrix form, u equal to n1 n2 into u1 u2. Now, you can put a number here also if you want. Okay, those who want right here. Now see, compare these two. Comparing. Okay. Now, comparing these two, see, you can write, if you want 3 and 4, u equal to, where is the answer? Comparing, u equal to half into 1 minus r, 1 plus r, u1, u2. So, compare, you can make out here, your n1 equal to, see, 1 minus r by 2, 1 minus r by 2, and your n2 equal to 1 plus r by 2, r by 2. Okay, this is the final answer. Shape function. Remember, the value of this shape function is the same as what you got by Cartesian coordinate. I will again see the time there. If available, again small extra information I will give. Remember, just for information, our part democracy is over. See, just for information, take an element of 200 mm length. You write the question. Node 1, node 2. Displacement at 1 is 0.6 mm to right side. Displacement at node 2 is 0.8 mm to left side. Sign is not given. Okay, start. We want to find what is the displacement at 2 points E and F. E is at 50 from here, F is at 80 from there. Okay, 80 from there, over. See, start. Displacement anywhere equal to n1 u1 plus n2 u2. Now, displacement at E equal to n1 u1 plus n2 u2. n1 n2 should be for the point E. For F point, again n1 u1 plus n2 u2, n2 u2, F for point F to be considered. Now, U is right side positive. As per given data, U1, see, U1 to right side and U2 to right side. U1 they told 0.6 right side, so plus 0.6. U2 they given 0.8 left side, so U2 minus 0.8. Okay, start. To get N1, N2 for both the points E and F, first I will do Cartesian coordinates. Origin here, X. See, for the point E, see the question here, for the point E, X equal to 50 mm. Why? Distance from here. Don't see F point now. Do not see F point. This is 50. Start. You know, Cartesian coordinate, N1 equal to, just now we got L minus X by L, N2 equal to X by L. So substitute. For the point E, X 550 substitute, N1 equal to 200 minus 50 by L will come 0.75, N2 will come how much? 50 by 200 equal to 0.25. And for the point F, remember they told 80 here, but X is from here. If that is 80, from left end, it will become 120. So for the point F, X should be 120 mm. Substitute N1, N2 you will get. How much? 200 minus 120 by 200, 120 by 200. N1 will come how much? For the point this one, N1 will come at the point E, N1 comes 0.75, N2 comes 0.25, and I write here now, and for the point F, space problem is there, I will manage here. For the point F, N1 you got how much? 0.4, N2 you got 0.6. This is by, based on Cartesian coordinate. Now, I will get the same value by natural coordinate, then I will substitute. 1 minute. Then only I will substitute. Okay, now consider natural coordinate r. See, there is no time now. I already told you, by the time you come to shape function, earlier only r is covered. So I am telling you have to believe. From originate center, r goes this way. For any point P, r equal to formula is x for that point minus L by 2 by L by 2 when origin is at left hand. So x minus half the length divided by half the length. Okay. Further details later in the course. I cannot explain further. Okay, start. For the point E, x is from here. How much x? 50 mm. Substitute 50 minus 200 by 2 by 200 by 2. Your r will come minus how much? 0.5. Okay. Minus 0.5. Therefore, n1 equal to 1 minus of minus 0.5 by 2, 0.75. n2 equal to 1 plus of minus 0.5 divided by 2, 0.25. So for that point E, n1 equal to 0.75, n2 equal to 0.25. See the answer there? Cartesian coordinate or natural coordinate, or tomorrow you start your own coordinate system if you want. Answer will be same. So whether you, irrespective of what, whichever coordinate system you consider, finally for the point E, shape function with respect to node 1 is 0.75, shape function with respect to node 2 is 0.25. Now come to the point F. Remember, x should be from left side. For the point F, they told 60, how much here? 80 they told here. If it is 80, this becomes 120. So x equal to 120, r equal to, see, 120 minus 200 by 2 by 200 by 2 will come 0.2. If you substitute r equal to, red color will paint, if r equal to 0.2, okay, n1 becomes, what is formula for n1? 1 minus r by 2, 1 minus 0.2 divided by 2 will come 0.4, 1 plus 0.2 by 2 will become 0.6. So for the point F, your n1 equal to 0.4, n2 equal to 0.6. See, therefore you can make a note, irrespective of Cartesian coordinate system or natural coordinate system, you got correctly for both the points, n1, n2 came correctly. Now start. Lastly, substitute and get displacement u at the point E and displacement u at the point F. See, displacement at the point E equal to n1 u1 plus n2 u2 equal to, for the point E, n1 is 0.75, I told u1 is 0.6 plus n2 is 0.25 into, I told u2 is minus 0.8. Minus 0.8. Answer will be 0.75 into 0.6 plus 0.25 into minus 0.8 comes to plus 0.25. Plus 0.25 millimeter. Or you can tell u for the point E is without sign. 0.25 millimeter to right side is the conclusion. Same way, come to the point F. Come to the point F. And this is for the point E. Okay, now come to the point F. Red color is not required. U at F equal to, again formula n1 u1 plus n2 u2, but now n1 n2 for the point F equal to n1 for the point F, how much you got? I see here 0.4 into u1 is 0.6. By chance, when I substitute, if any calculation mistake is there, adjust it. Sometime happens. I might have given 0.8 here, 0.6 there. I can't remember. I will tell one thing. In my class, there can be calculation mistake or spelling mistake, etc. Technical mistake will not be there. Plus n2 is 0.6 into minus 0.8. Substitute 0.4 into 0.6 plus 0.6 into minus 0.8 comes to minus 0.24. It is minus 0.24 millimeter. Therefore, displacement for the point F equal to, see, this is UE right side, positive came right side. This is UF right side, negative came, don't put sign now, 0.24 mm, not right side, negative came, that much left side is the answer. Okay, now I think I made shape function, its calculation, and what is the meaning, application, somewhat clear. Go through the class again and again, and whatever I told, use it for your future study in case you are studying your own. In case you join the course here, you don't have to remember everything. These all will come in very systematic way. See, today, because of time problem, I have to slightly hurry. I know I can in the class I will ask the question with the students. I will ask them what is the answer. I want them to tell, not that I don't know, but when they tell if it is correct, I will accept it. If wrong, I will correct it. Okay, that all you can see when if you join the course. Okay, now I will leave here only. Goodbye to you all. All the best for examination to everybody. For not only this examination, for any examination in future you face. Okay, thank you for going through the class.